youngest of the two boys because he's...
Lola Cross-White is in the early stages of a disease that affects some 4 or 5 million Americans. And is perhaps the one affliction we all fear most. The disease, which begins by robbing us of our ability to remember, is of course Alzheimer's. When did you first start to notice that you had a problem with memory?
I'd go to the telephone would ring, and I'd go to take a phone call. And, I'm sure I was making all kinds of sense when I was talking because everything was very easy and that sort of thing. And I realized by the time I would hang the phone up, I hadn't a clue to what had been said.
Didn't know what you'd been saying? Could you remember who you were talking to?
Sometimes and sometimes not.
In terms of someone in the early stage of Alzheimer's, what does that mean to them? What do they go through? What's their life like?
What they primarily have at the early stages is problem forming new memories. Mm-hmm. But everything that they ever were is still there. And that judgment, that human being is still there and is as precious and wonderful as they ever were. But the problem is short-term memory. That
was the sort of the first thing. And then it began to be that I would get very confused. I would start to do something, and then all of a sudden I kind of would forget what I was going to do, and then the more I thought about it and the more I agonized about it, the more confused I'd get.
And with time, that is joined by other symptoms that include problems sometimes recognizing things, sometimes with speech, sometimes problems remembering how to manipulate objects. And by that point, we're into the middle stages of the disease, and that takes a few years. And then after that, there's more global decline in cognitive function when the disease really becomes severe.
In these images compiled from scans of living patients, a wave of destruction moves inexorably through the brain, turning it from healthy blue to dying white. First to go is the hippocampus, and so the ability to form memories, followed by the areas involved in emotion and reasoning. Spared even to the end are basic functions like sight, hearing, and touch.
Okay, watch your step.
One of the real breakthroughs in Alzheimer's research is coming from new technologies to detect the disease much earlier. Here at UCLA, for instance, a technique called positron emission tomography, or PET, is being employed to pick up subtle changes in how well cells in the brain are firing. In a healthy brain, cells firing normally show up color-coded red. In an Alzheimer's brain, the blue regions are where cells are failing to fire, notably in the memory centers around the hippocampus.
These scans are so sensitive that in many situations we can diagnose Alzheimer's disease sometimes years before the doctor can arrive at that diagnosis in a clinical setting.
That's really fascinating. You can look into a person's head and tell that they're getting Alzheimer's before the symptoms show up? I mean, before the family might be troubled by it?
It makes sense, because if you think about it, the brain is a very adaptable organ in the body, and we've done other studies where we find that people with very subtle problems, so they sort of compensate for this deficit that is there that we otherwise can't see. So the pencil and paper test won't show us anything, but the scans will. And when we do these scans, we can see that those cells are not firing as well as they should.
A scan that detects Alzheimer's even before symptoms appear means treatment could begin much earlier, before the brain is ravaged beyond repair. But that, of course, depends on there being effective treatments. And today there is a growing sense of optimism among Alzheimer's researchers that such treatments are at least on the horizon. When someone has Alzheimer's, what's happening inside their brain?
They're building up tiny amounts of these nasty molecules that shouldn't be there, that aren't there really early in life, and that over time, in the 30s, 40s, 50s, and 60s, start to build up. And the molecule is okay when it's just in singlets, if it's just a single unit of this at a place. When it doubles up and gets into bad company, so to speak, it gangs up into doublets or triplets or quadruplets, that's when it causes trouble. And we think that that's the cause of the disease.
The molecule is called what?
Amyloid beta.
If Dennis Selko is right, and it's these killer molecular gangs that destroy brain cells, then there are two ways of tackling the problem: prevent the amyloid beta buildup in the first place, perhaps with a drug, or get rid of the amyloid beta before it can reach dangerous levels. This second approach has been dramatically successful, but so far only in mice. These mice have a version of human Alzheimer's disease, and when mice like them were injected with an antibody that removes amyloid beta, they showed every sign of being cured.
It's like a miracle, basically. There was this one study in a group at Lilly, Eli Lilly Company in Washington University, where they tested the mice on whether they could recognize objects. And they couldn't. These were Alzheimer engineered mice. And they gave them one shot of the antibody and tested them again the next morning. And lo and behold, these mice could now distinguish two objects that they couldn't before. They returned the mice from their 23-month-old status, which is old for a mouse, down to the level of a 5-month-old mouse, which is young. So, we can only hope that such a thing could happen in humans, maybe get close to that.
But when 2 years ago a vaccine against amyloid beta was tried in humans, the trial had to be stopped when one of the patients died from inflammation of the brain. Meanwhile, Dennis Selko, working in collaboration with his old friend Howard Weiner, had come up with the idea of giving the amyloid beta vaccine not as an injection, but as nose drops.
They sniff it. It's like a nasal spray, but it's inhaled.
The vaccine works, clearing amyloid beta from the mouse brains. And because there are theoretical reasons to suppose that a nasal or oral vaccine won't cause dangerous brain inflammation, the Harvard team is now hoping to soon begin human trials in a small number of Alzheimer's patients.